Okay, well, let me start by saying what a conjunction is before I tell you what a great conjunction is. A conjunction, generally speaking, is when two celestial objects are near each other in the sky, as seen from Earth. When we have people on Mars, maybe there'll be conjunctions that people on Mars can see. Um, and that happens more commonly with the planets because the planets orbit in about the same plane that the Earth orbits around the sun. And so they're going to be more likely to get close to one another over time. A great conjunction is the conjunction of Jupiter and Saturn. What's great about it is they're really bright. If you have a conjunction between Mars and Pluto, it's probably not going to be very awesome. And a lot of the conjunctions are with planets that are too faint to be seen with the naked eye, or conjunctions that happen to be in a place that's too close to the sun, so you can't see them. So again, a great conjunction would be conjunct between the two brightest planets. And what makes this year's great conjunction even greater is that they're very, very close together. And they're very visible in the night sky just around sunset. They're about 30 degrees above the horizon in the west. Um, there have been great conjunctions before, but the most recent great conjunction that was this close, a great conjunction is just Jupiter and Saturn. This year's conjunction is greater still because they're very close together. In the 1600s, there was a very close great conjunction, but it happened in the daytime, and so people couldn't see it. So uh, the thing that's unusual is that Jupiter and Saturn have a conjunction about every 20 years. And what's really unusual this year is that they're so close together. They're going to be about a tenth of a degree apart. The moon is about half a degree. And so if you could imagine looking at the full moon, Jupiter and Saturn are going to be as far apart as about a fifth of the full moon. So that's very close. And of course, since they're very bright, it's easy for everybody to see it. What happens in general is that planets, of course, orbit the sun, and planets closer to the sun make their orbit quicker. And so, Mercury goes around in about 88 days. Obviously, the Earth goes around in 365 days. Jupiter and Saturn take much longer. But Jupiter is closer than Saturn, and so even though it takes a while for Jupiter to get around the sun, Saturn takes longer. So what happens over time is that Jupiter, from our perspective here on the Earth, will appear to catch up and pass Saturn. And like I say, that happens about every 20 years. And so if you go back and look at, 2000, there was a conjunction of Jupiter and Saturn. I don't recall how close the planets were, and I don't recall if it even happened, in the daytime, so people couldn't see. But because of the number of planets and the different periods of their orbits, conjunctions are actually common. Great conjunctions, not so much. But I went back and looked because I didn't remember. Last year, 2019, there were actually 19 conjunctions of planets. And logically, it makes sense that most of those involve Mercury and Venus, because Mercury and Venus go around the sun so rapidly that they catch the planets all the time. And so I think 18 of the 19 conjunctions in 2019 involved Mercury or Venus catching one of the other planets. The other one was Mars, I think. So again, conjunctions are common. Jupiter and Saturn conjunctions are not, because they happen every 20 years. And the reason the distance varies when the conjunction happens is because the orbits are almost in the same plane as the Earth's plane around the sun, but not exactly. And so they may be a little bit above the plane of the Earth's orbit, a little bit below the plane of the Earth's orbit. And so the actual separation distance of the two can vary a little bit. And that's why this is unusual this year, is because it turns out just by chance that they happen to be very close to together. And that isn't always the case. Apparently close together as you look at them in the sky. Obviously, Saturn is much, much farther away than Jupiter. And so, they're not physically close. It just happens to be that if you look at them, they appear to be next to each other in the sky.
So
yeah, line of sight. They're very close together on your line of sight, but they're not actually close together. Solar eclipse in South America, and that's another example. That's a conjunction, the moon and the sun. And if the line of sight gives you the eclipse because the moon covers the surface of the sun. So they're actually right together. It's more than just a conjunction. It's actually an eclipse. But of course, the moon and the sun aren't physically close together. It just happens that they appear close together during an eclipse. In fact, they appear to be at the same place, as a matter of fact. Original view of the cosmos, which we have the Greeks to thank, was actually pretty skillfully done based on the observations they had available. I mean, think about it, that was way before telescopes, so you just had what you could see. And what they saw, they were able to explain in ways that kind of made sense. In particular, it made sense because you could put the Earth at the center, and then the Earth's the center of everything, which we like. And then you can explain everything else you see by planets and the sun and the moon going around the Earth. It wasn't until, frankly, Galileo, who first used a telescope to look at the sky, that we had observations now that you couldn't get easily with your naked eye, which called into question what the Greeks had thought. And suddenly, for example, Galileo was able to observe what appeared to be tiny objects going in orbit around Jupiter. We know today, in fact, we call them the Galilean moons today. They were the four largest moons. And that does not prove that the Earth's not the center of the universe, but it does prove not everything goes around Jupiter. I'm sorry, not everything goes around the Earth. Some things go around Jupiter. You can see that it actually goes through phases like the moon does. And that is totally inconsistent with a model that has the Earth at the center. And so, but these beliefs had been in place for so long, and of course the Greeks were smart guys, and if the philosophers told you this is how it was, people accepted that. So it took a while, but eventually, when we had enough observations and people began to realize this model isn't working, then they had to adjust the model. And of course, that's how science works. You have a hypothesis, you make predictions, you take some experiments, make some observations, test it against your predictions. It works or it doesn't. If it works, great. If it doesn't, maybe you can save your hypothesis with some tweaks. If it's bad enough, you have to get rid of it and try something new. And that's how we make progress. No, it's just a coincidence. It's a nice coincidence because the 21st, the solstice, is the longest night of the year, and so you got more time to. Now it doesn't help us here in Kansas because the Jupiter and Saturn are going to set pretty quickly after the sun does. So the night could be as long as you want, and it's not going to add to the amount of time you have to observe, but it will add to the amount of time that other people may have to observe it. I think the great conjunction is a rare occurrence. I mean, a lot of the articles I have seen talk about, the last one where it was this close was in the 1600s, but it wasn't visible. The one before that was in 1226, I think. And so this is a very rare opportunity. Um, Having said that, actually conjunctions are fairly common, and so Mars with other planets is. We had. I went and looked it up. We had a Mars Jupiter conjunction in March, and we had a Mars Saturn conjunction in April this year. So maybe this is an opportunity for people to get excited about, the next great conjunction won't be for 20 years, but Mars conjunctions are far more common, and maybe people start being interested in seeing what they can learn about that.